Hello, and welcome to the Origins Podcast. I'm your host, Lawrence Krauss. Lord Martin Rees is one of the most distinguished astrophysicists in the world. When I entered cosmology after a background in particle physics, I had to quickly determine who I could best learn from and which papers were reliable, and I honed in on Martin for both purposes. As I got to know Martin more, I discovered what a voracious reader he is. He seems to read everything that comes out in science. And he's devoted some of his own time as well to popularizing the field. Beyond his remarkable scientific career, he's taken on many tasks to serve society. He's been the Astronomer Royal, Master of Trinity College, President of the Royal Society, and now he's a member of the House of Lords. Clearly, his interests are very broad, and we are able to have a detailed discussion of modern issues in cosmology, but also about the political situation in the United Kingdom and the United States, and public science writing, and even the role of religion and religious figures, about which we don't see eye to eye at all, and you may catch a glimpse of that. Whether we agree or disagree, I come away from every conversation with Martin both enlightened and motivated. I hope you will too. Patreon subscribers can find the full video of this program and all our programs immediately upon the release at patreon.com/originspodcast. I hope you enjoy the show. Well, Martin, it is always a pleasure to talk to you. I always learn things and am enlightened. And so I'm going to enjoy being enlightened over the next little while as we chat. And I want to ask you some questions I've remarkably never asked you in our times together. First of all, I've never asked why you became an astronomer. What interested you as a child, or what determined that path?
I didn't have that vector early on. Mm-hmm. As a kid, I was keen on numbers and nature, etc. And in the English schools, you have to specialize in your last 2 years in high school. And because I was bad at languages, I specialized in science. And then I proved to be quite good at maths. And so when I went to university, that's a subject I did. And I realized I wasn't enjoying it. There were some other students who clearly had the mindset of mathematicians, and I didn't. And so when I got my bachelor's degree, I tried to think of some way in which I could use it in a more synthetic and synoptic style of thinking, which is the way I like to think. And I thought quite seriously of doing economics.
Oh, I'm so glad
because I had two friends who are still friends who started it, and they went that way. And just by a chapter of accident, I ended up doing astrophysics in Cambridge. And this was lucky for two reasons. First, I had an excellent advisor called Dennis Sharma, who was a very good scientist and an absolutely great coach, if not a great player.
He has some very distinguished students.
Well, he was lucky,
players.
and we all learned from each other, of course. And also, this was a very good time to go into the subject because I started in '64, and that was before the microwave background, first black holes, etc. And I always like to say that if you're picking a subject, pick something where new things are happening or new techniques, because then the experience of the old guys is at a heavy discount. And if you're young, you can start to make an impact fairly quickly. And I was quite lucky in that sense.
It's interesting. Let me ask you about, I did a degree in mathematics and one in physics when I was an undergraduate.
Yes, I didn't do physics, and I picked that up as I went along.
You picked it up pretty well,
I'd done better if I'd done physics and not mathematics at Cambridge.
I think, as a preparation for astronomy, I think, on the other hand, as I tell people, I've learned more since my PhD than before.
Well, I think that's true, and I think I was badly taught because no one explained why you might want to diagonalize a matrix, for instance. And so it didn't relate to anything that I might have wanted to apply it to. So but I think bad teaching, but I did realize that I didn't have the mindset or the ability of the people who ended up being professional mathematicians.
It's interesting you say that. I often say that when I was chairman of a department once, that people talked about whether it was okay to move the physics earlier because people hadn't taken something called differential equations and vector calculus. And the experience of all the students who I talked to, including myself, is that you could do that in mathematics, but until you saw it in physics, you really never understood why you were doing it or what. So doing it coincidentally at the same time, seeing how it's applied in the real world, makes it much easier to understand the mathematics, I think.
I think so, except some mathematics people appreciate for its own sake.
Yes.
And I didn't get to the stage of having that appreciation.
Did you ever know Dirac when he was at Cambridge? Did you ever? Because he was one.
I went to his lectures.
You went to his lectures?
Yes, in the about 1969, about his last year, and. No, 64, must be. Yeah. He lectured for a proof copy of the latest printing of his classic book. He thought he'd said it very well then, why change it? And he spoke in a rather dull way and wrote rather clearly on a blackboard, etc. So he was not inspirational, but it was a living fossil who was great to see, of course.
Great, amazing. But he was one of the few, well, I've known a few physicists who basically viewed the mathematics and the mathematics illuminated for him rather than the sort of he obviously did very important physics and his intuition ended up being great, but he was driven by the mathematics and the allure of the mathematics.
Well, that's right. He famously said that the beautiful mathematics was likely to lead to something, and you should follow through the implications of the mathematics, and that may predict some new physics. And of course, it did. It did in the case of the positron for him. Yes.
Yeah, as you mentioned actually in your recent book, I was reading that, and as we all. That famous essay by Wigner on the unreasonable effectiveness of mathematics, which I sense now we have a better understanding of why mathematics works well for the world. But maybe at the time it seemed more serendipitous. But now when we think of, at least from a fundamental perspective, we don't think, at least as a physicist, we don't think of the equations as so much as the symmetries that govern the nature of the equations, and the symmetries are described by mathematics. Right. So it seems to me to be less surprising or unexpected. Well, one of the things I learned about you, that I didn't know, was your parents started a new school, and you went to it for when you were younger. Is that
did,
correct?
Yes. Mm-hmm.
What was it? And it had a modern sort of quote modern. What was their modern curriculum or whatever?
Not especially modern, actually. It was a school, and I had a really fortunate childhood, not so much with the education, although I was well taught, but it was in the wonderful surroundings in the country. Yeah. So I grew up in a village and having the freedom to roam in a beautiful countryside.
Yeah, which you maintain, right? You now live in a converted farmhouse, right? Or
right, yes.
So you maintain that the rural. The Rousseauian.
Yes, I could never live in an apartment.
Yeah, the love of nature, the primal man and the beauty of nature. Okay, well, when did you know? I mean, did you know even when you were pursuing your PhD that this was the direction that you were going to become an academic, or was there at the time? Did you think it was a stepping stone to potentially something else? Or
no, I think when I started, I was diffident and uncertain, but after a year of working as a graduate student, I got enthusiastic and I was convinced that I was going to enjoy it. And therefore, when I got my PhD, I did try to get some postdoctoral position, and was glad I did.
Yeah, we managed to do. Was it any specific thing that turned you on, you on and said, this is the right path for me?
I don't think so, because it was interesting, because the microwave background was discovered, and I realized it was possible to have some new, simple ideas which were relevant to
For some listeners, I guess that there was a sea change, and even it was a little early for me, although, so in terms of understanding the significance, but one of your, I guess someone who was potentially a mentor of some sort, Fred Hoyle, there was a big debate about whether there was a Big Bang, and I mean, while the microwave background was discovered, which is the remnant of the Big Bang, that we now recognize as the remnant of the Big Bang, was it immediately? I mean, in retrospect, we often make it sound like something immediately changed. There was a paradigm shift. Was there a paradigm shift at the time? Was it immediately recognized as unambiguous? Did people change their minds or not?
Well, I think in a year or two, they had to have data at different wavelengths to see if the spectrum was thermal. But I think it did convert almost everyone at that time. Fred Hoyle himself was never fully converted. He tried to have elaborate theories, and I would say ended up believing in what I call a steady bang, some compromise model. And of course, I hugely admired Fred Hoyle, but I never really worked with him because he'd started to go off in slightly eccentric directions at the time when I started to be in the subject. But he was a really great figure in the subject if you look back at all the things he did.
He had an immense impact, and certainly well, these things are always. I know your view about awards, and I share it in many cases. But he did work that certainly was on par, and many people could say worthy of a Nobel Prize.
Of course, well, he should have got it for his work with Fowler. But more generally, he was a real polymath and very inventive, and made lots of contributions to all branches of astronomy
and
of
literature.
Course, but he also enjoyed debate. And before the microwave background was discovered, there was, as you say, the steady state theory was advocated by him and Bondi and Gold.
Yeah.
They were three sort of very noisy and articulate people.
Yeah.
I don't think they carried much resonance outside the UK.
Oh, really?
Certainly not in Russia or not in America either. But in the UK, it was an important debate. And the debate involved the radio astronomers, because they were the first people who found evidence that the universe couldn't be in a steady state, because they found that there was more evidence that radio sources were strong, and that radio galaxies existed, spewing out radio waves in the past than now, contrary to what you'd expect in a steady state.
Yeah.
And this was a debate where Martin Rees was correct. And I listened to these debates in the 60s, and I felt that Hoyle was perverse not to take them seriously. But then I read more history of the subject. I realized that in the 50s, Ryle had been equally dogmatic when he'd been wrong.
Oh, I see.
And so I understood that Fred had a reason for being somewhat skeptical, whereas I came fresh on the scene, and Ryle seemed to be talking a great deal of sense. And indeed he was at that time, but he had been dogmatic and wrong,
I see. So
and had earlier standoffs with Hoyle and Gold.
Well, that brings to mind a bunch of things, but not least someone told me it really wasn't Max Planck that said this. I've always attributed it to Max Planck, the famous statement that physics proceeds one funeral at a time. Do you know if you're a scholar?
I've heard it attributed to him. Yes.
Yeah. So that young people are not burdened by the biases or prejudices that have come up over time in the past.
But of course, this does raise the question of what happens to scientists when they get old.
Yeah.
Something which is of concern to me and even to you.
And to me, yes.
And I think there are three routes. I mean, many of them just do less science, become administrators, or sink into torpor in some form. Some overreach themselves and go to new fields. And Hoyle, Shockley, Pauling, and others, Eddington, they're people who they would still say they're motivated by trying to understand the world, but they no longer get satisfaction from the routine stuff they're good at, and they try and do something where they're not experts. Of course, Fred Hoyle did this sort of thing in his old age, attacking Darwin, saying that flu epidemics came in on comets and things like that.
Okay.
He did a lot of, so that's the second way. And the third way is, of course, to go on doing what you're good at, and realizing that your work will be on a plateau and you won't get better. And I think it's interesting to see why it's the case for many artists, certainly painters and composers, that their last works are their greatest. But you wouldn't say this of many scientists. The best they could do is stay on a plateau. And I think the reason is that if you're, say, a composer, then you're influenced by the musical environment when you're young. But thereafter, it's just internal development.
Okay.
Whereas in science, it's a collective activity. You've got to be able to absorb new techniques and new data, new ideas.
Exactly.
And that's what we get less good at when we get older.
Absolutely. I mean, I mean, there are rare exceptions. Of course, to every thing like this, there are exceptions. But example of being a most famous example is Einstein, who was incredibly in tune with what was current at the time.
That's right.
But then later on, sort of refused to accept what, or at least refused to be in touch with what the key experimental things that were going on. His obsession with unifying electricity and magnetism became an anachronism, because already in the 30s we knew there were other forces in nature, and it was kind of it was not you couldn't unify.
It was premature to do it. Yes. But also he didn't really follow through on the implications of his own theory, did he? I mean, he didn't work on black holes. And he was in the same place as Oppenheimer for 10 years. And Oppenheimer had done this wonderful paper in 1939, which was a step towards understanding gravitational collapse. And they never discussed it, I don't think.
That is fascinating. Well, so I guess the idea is to try and keep an open mind and listen, but it gets harder because I think the other problem...
Keep your mind ajar and not completely vacant.
Yeah, exactly. Yeah. But also, the more accomplished one is, that sometimes when I've seen people get the sense that they should therefore only be working on things that are profound and important, when in fact, most of the time when you're a scientist, you're working on little things that are interesting you, and my friend Shelley Glashow calls them pieces of grizzle. So if you're always trying to solve grand problems, you rarely make any progress.
Right, but only cranks and geniuses work on the big problems in one go. You've got to work in a piecemeal way.
Yeah. Although the other thing about Hoyle that I do appreciate is he was a good science fiction.
Indeed, he was, yes.
And
I mean, his first book, The Black Cloud, was the best. He took more trouble over that, and the hero is a handsome version of him, of course.
Okay, excellent. Yeah. Well, I first learned about that when I was from Freeman Dyson when we were debating the long-term future of the universe, and he was the first one to tell me. We talked about whether intelligence could survive, and the black cloud was an interesting example that he tried to present as a counterexample to our debate. And
right, it's the only kind of intelligence you could have in a universe that was nuclear free with only hydrogen.
Yeah, exactly. Although we both agreed in the end that the future of the universe, that in the universe that we think we live in now, black cloud, you still couldn't have life forever, even in the form of a black cloud. But we don't know.
You think too slowly.
Yeah, exactly. Well, what was the biggest surprise? What's been the biggest surprise to you in your career in studying astronomy and cosmology? What unexpected thing changed your thinking of the world more than anything else?
Well, of course, I came in fresh when the microwave background and quasars were being discovered. I mean, I suppose the biggest thing is really exoplanets.
Interesting.
I think, yeah.
So
and it's not fundamental because, of course, what's happened is that we understand the Big Bang back to a nanosecond. Before that, the physics is uncertain, and we understand the formation of structure. But we don't understand all the complex structures that form.
Absolutely.
And I think exoplanets make the night sky far more interesting, and also open up the possibility that we can make exobiology a real science with real data.
Yeah, with real data, which it isn't yet.
That's right.
There's a lot of talk, a lot of heat, not yet so much light.
Yes, but some of serious experimenters and theorists have been motivated to think about
exactly, which precedes a lot of. I mean,
because people don't realize that although we've got Darwinian evolution, we still don't know what causes the transition from complex chemistry to the first replicating, metabolizing entities we call alive.
My sense is that before we can make extreme progress in understanding life in the universe, we have to understand the nature of life here on Earth. I'm not sure. Do you think that what we see and learn from exoplanets will illuminate and help us understand the evolution of life here on Earth?
Well, I think we've got to do both. First, I think that the people thinking about the origin of life on Earth, which is, of course, a problem that even the most firmly ground-based biologist cares about, they ought to be able to tell us, was it a rare fluke or not? And also, was there something really special about the DNA, RNA base that we have? Or could there be other quite different forms of life? So I think we'll know that in 10, 20 years. And I also think that we will have some clues as to whether the biosphere is elsewhere. We may find something under the ice of Enceladus or even on Mars, but we will, I think, with the next generation of telescopes, have some spectral evidence about some of the Earth-like planets orbiting nearby stars, which will tell us, are they green? Is there evidence for a non-equilibrium atmosphere, etc.? And so I think within 20 years anyway, it's not absurd to think we will have some evidence as to whether there is a biosphere on another planet.
Whether we're unique. I mean, I can't imagine that the answer won't be yes, but do you agree or?
Well, I think I bet that there will be other biospheres. It may be more than 20 years before we are convinced of that. But of course, whether those biospheres evolve into anything like what happened here, anything interesting, certainly anything intelligent, is
that's
quite
a
separate question.
Because we're here by. I mean, there's no evidence that intelligence is an evolutionary imperative, or I mean, we took 4 billion years on Earth before we get this kind of intelligence. So I agree. That may be much more special.
Yes,
but it's hard to imagine, given that at least to me, given that life evolved on Earth about almost as soon as the laws of physics could have allowed, and that the fundamental constituents, water, organic molecules, and sunlight and energy, is kind of ubiquitous throughout the galaxy, I have a hard time believing that life itself, that kind of life itself,
no, so do I. I mean, logically, it could be it was unique here, but it does seem unlikely. I agree.
But at the same time, I'm a little worried by claims about habitable planets, which are every time a new planet is discovered and people talk about it being habitable, and the habitable zone is described as sort of where liquid water could survive. But as I like to point out, even on Earth, there were times in our history when certainly the Earth is a habitable zone. We know that, but it's been frozen over solid, and so the detailed climate, and it depends on continents, all sorts of things which are sort of far too complicated right now to put in the models of exoplanets. So I think it indeed is a little premature from my point of view. What I did make a bet actually with a public bet now, I think, with Richard Dawkins. I can ask you. My bet is that if we find life, not so much I'm worried about Mars because we can pollute. I mean, we're not sure if we're not Martians or vice versa because life will pollute each other. Yeah. But if we found evidence of some life under Enceladus or you pick your favorite moon, that I suspect it would be almost identical. That I tend to think that life is governed by chemistry so much that even the base pairs, that even the genetic code, I think would be the same four sets. And he thinks it's impossible, but I made him a bet.
Well, I don't know. I said that's the second thing we may learn.
Yeah.
From these results. But of course, if we did find life on a moon around Saturn or Jupiter, that would be crucially important.
Yes.
If it evolved twice within one solar system,
then it's everywhere.
That immediately says it must have happened millions of times in our galaxy.
Do you want to take the bet with me, because he's promised an extremely expensive bottle of wine? I know.
I'll stay out.
Yeah. No. It'll be interesting to me. There'll be so many fascinating things. Yeah. But on the other hand, if we discover extant or extinct evidence of life on Mars, I think, and if it was identical, most of us would not say it's independent. I think, in fact,
there's a possibility that it went from one planet to the other.
Yeah, I think. Well, I think Andy Knoll, who's a evolutionary biologist, early studies early life on Earth, had said once that he would be amazed to not find evidence of our cousins at some level on Mars, but simply because microbes can travel back and forth. And if they arise on one planet, they can pollute. They will naturally, I think, pollute other planets. So it'll be interesting to see.
They may not survive.
Yeah, exactly. Yeah. See, okay, well, that's fascinating. The exoplanets. I think it's really interesting that. So would you say that? Well, one of the things we've learned that's most surprising to me about exoplanets, and maybe I don't know you, is that almost all of our wisdom about solar systems and what is possible in solar systems has been wrong. In the sense that things that we thought couldn't exist, giant gas giants near stars, and everyone thought. I mean, the kind of a presumption always is that you're typical, and that therefore our solar system is typical. But now we see that not necessarily that at all. That far more things exist in heaven than are dreamt of our imagination. I think.
That's right, and data gathering is going to hugely clarify, allow us to classify planetary systems, and as I say, it leads to chemistry and complex biology, perhaps. So I think that's a fascinating subject. But of course, going back to fundamental cosmology, I hope we will understand better the first nanosecond and why the universe expanded the way it is, and has a mix of constituents, what the dark matter is, etc. And of course, whether our Big Bang is the only one.
Yeah, those are the big questions, and I've become a little more optimistic. In spite of the fact I'm generally pessimistic by nature, I think although, as my friend Cormac McCarthy said, that's no reason to be gloomy. I used to think there'd be no hope of answering of having any empirical answer to many of those questions in my lifetime. I'm now not convinced. Even the possible existence of other universes, which I thought would always be metaphysics. I think if we, I've written about this too, as you probably know, that if we can discover evidence of primordial gravitational waves, it may give us enough evidence to understand a theory that tells us, even if we'll never know about them, that the theory tells us other universes by this thing called inflation were created.
Yes. Well, that's one way, but the other point is, if we have a theory that applies at 10 to 16 GeV,
which is about, just for the listeners, it's about 16 orders of magnitude in energy more greater than the energy associated with the nuclei of atoms and
right.
Yeah.
And it's the energy which particles had at the epoch of inflation, if you
Yeah.
understand the pictures. And if the physics had the properties that are needed to give rise to Andre Linde's eternal inflation
Yeah.
model, which is specific,
Yeah.
then, of course, we would take that seriously if that physics had been corroborated in other ways.
Yeah.
And so the question is, it might be corroborated by primordial gravitation waves, but better still, obviously, would be if it does explain things in the low energy world.
Of course.
Why there are three kinds of neutrinos and things like
all
that.
the things we don't understand. And if it maybe could be corroborated by terrestrial experiments underground, looking at properties of protons, which I won't go into now. But it'd be nice. Well, actually, it would be really nice because one could point to the other. If a discovery in cosmology was made associated with that, it might point to the kind of physics that one would look for under large underground. There's a great symbiosis there. And I think it's a long shot, but it's amazing to me that it's even possible that we might know, without clearly ever being able to measure the existence of other universes, that we might have enough confidence, just as perhaps in 1905, by 1905 or a little bit after, people accepted the existence of atoms, when at the time I think everyone thought we'd never ever be able to see them, but it was pretty well accepted. Not 1905, but by 1906 or 8.
Yes.
And it's amazing to me that metaphysics, in that sense, we become physics. That's always progress. Anytime we can reduce the domain of metaphysics and increase the domain of physics,
but it's a big jump to get from the scale of atoms to the scale where space and time have granularity, which is a trillion times smaller than atoms.
It's a long shot, but
it's certainly possible. And I think if that's the case, then there are two big questions. You want to ask, does this physics indicate the likelihood of many Big Bangs? And then also the other related question is, do the different Big Bangs cool down to be governed by the same physics, or are there really many vacua? That's the other big question.
Yeah, because that changes, it seems to me, the whole question of fundamental physics. When I was growing up, I wanted to do physics because I wanted to understand why the universe has to be the way it is. But in fact, it may be that could be just the wrong question. Our universe, just the physics may be what it is, just for no real, because it could be anything, and we just happen to live in a universe in which we could evolve. And
just like we happen to be in a solar system with the planets as they are.
Yeah, in fact, there may be nothing more fundamental about that than there is about the famous radii of the planets around the sun, which early on Kepler and others thought had some profound significance. It's just largely an accident. But I think it's interesting that of all the things that I'm fascinated by, the exoplanets, which indeed are not from a fundamental physics perspective surprising, it's your biggest surprise, because that's fascinating. Would you say that we should
perhaps I suppose neutron stars, in a sense, were a big surprise, weren't they, when they came? They were a huge to find they existed. And of course, they've kept on for the last 50 years, revealing amazing new things.
In fact, actually, you've made a perfect segue, because I was going to say, recent news, in some ways, is more intimately related to you made had a profound impact in a wide variety of areas of astrophysics and cosmology, and I've always. I used to, I'll tell you this, and I'll tell you it publicly. When I didn't know much astronomy and cosmology, I decided that, there's lots of stuff being written, and what you have to do if you're a young scientist is learn who's more likely to be trustworthy, and maybe lead. So there's so much you can read. And I always told myself, well, if I'll read Martin Rees, because so just so you know. But getting back to a subject which, as I say, I think is more related to fundamental work of yours, and this new. I wanted to kick your take on the significance of the new observations of black hole, which is captured, at least among the public, the fascination, a picture, a reconstruction, not a real picture, but a reconstruction of the image of a black hole.
Yes.
How did it impact on you?
Well, I think it was a huge technical achievement to be able to link together the data from 8 telescopes around the world and recover the fringes and all that. So it's a great technical achievement, and it's very nice to see the picture. In terms of evidence for a black hole, I think, to be honest, it's just a marginal step forward. Indeed, already from X-ray astronomy, we had evidence of hugely Doppler shifted and gravitated redshifted broad lines.
And also one of your fundamental discoveries, if I could call it that, is the fact that basically black holes and collapsing systems would produce incredibly energetic jets, which have also been observed.
But they could have come from other things than black holes.
Yeah, but
so we don't know. And indeed, incidentally, if they hadn't found the dark circle in the middle, then the explanation I would have given would be that the jet is pointing. Well, we know that in this galaxy, the jet is 20 degrees away from the line of sight. And the one thing I was hoping we'd learn from these particular observations was something about the base of that jet. In particular, was it wider than 20 degrees? So sun was coming towards us. And had that been the case, it would have sort of blinded us to the extent that it would have filled in the hole.
Yeah, sure.
And so we've learned something about constraints on the theory of the jets.
But was the prediction that it would be not less wide? That you would it have surprised you if it had blinded us? Would it have surprised you if the jet was so? Let's make it clear that what we're talking about is that there's this dark hole, but of course if there was energetic radiation being emitted outside the black hole and it was pointing our direction, of course it would blind us to the what's behind it, which is the black hole itself.
Well, I mean, there are different theories, and done by a number of people, and some would have this property and others wouldn't.
Okay,
so the extent to which
something's been ruled out, I guess.
Yeah,
that's right. It's made an impact.
But what's been ruled out is something which is not sort of deeply relevant to black hole horizons, but it's something which is relevant to astrophysics. And perhaps jets is something I have worked on a lot. And one of the reasons why I feel a dinosaur in much of my scientific work is that many of the things that I did were done at a time when the best you could do was have some simple symmetrical models. Whereas now, because of the far greater power of computers, it's possible to do realistic simulations of many of these problems. And indeed, to think of what happens if magnetized gas flows around and falls into a black hole, etc. And that's been a huge advance in the subject. And that's why if people ask, should they work with me on this, I say no. Work with someone who's more adept at coding and understanding this sort of computation. Because since we can't do any experiments in astronomy, we can, in the virtual world of our computer, do experiments. And they've hugely advanced our subject.
In every way. In fact, I mean, once again, the other major advance, the discovery of gravitation, the direct discovery of gravitational waves, not the indirect, would have been impossible if you didn't have computers that could produce models that would give you what you'd expect to see, so you could compare it against observation. That would have been totally impossible. So I like to say that these observations couldn't have been more timely or even done earlier, not just because the experimental apparatus has only required the advances in optics and everything else we need, but the theory wasn't adequate.
Well, that's right, to actually compute objects in a non-fixed space-time.
And
it was a big challenge.
They came together always. Well, I think it's nice that I sort of course, agree with you. I think it's nice it's captured people's imagination. And anytime people get excited about this, it causes them to think and ask lots of questions, which is good. I think I tweeted that it was a triumph of human ingenuity, which I think is it's not a triumph in the sense of changing the forefronts of physics, but the fact that people could do it and were willing to do it and thought they could do it and devoted years of time to doing it. And it worked. Is it just as someone?
It's a big step forward in interferometry.
As a theorist who works on a paper that sometimes they take months or years, but usually you can do it in a few months. And it's compared to the time, the dedication that's required. I always find that amazing. I couldn't do that myself. I think it would be. It's not the way I work.
And going back to Ryle and Hoyle, we mentioned earlier, Hoyle loved debates, and Ryle got genuinely upset and didn't enjoy debate. But there's an excuse, I think, in that Fred Hoyle, if one theory was shot down, he'd think of another one the next day. But Martin Rees has spent years building instruments.
Oh, I see.
And people who've done that, they've got to feel it's going to discover something important.
Yeah, well, you can't, if you don't feel that, you wouldn't spend the time on that.
That's right.
And it's true to some extent for theorists who've worked for 20 years. The string theorists, if you work for 20 years on, you have to feel that it's got to be right, whether it is or not. The hallmark of a true scientist, of course, is being willing to throw, even if you spent 20 years, being willing to throw it out when the experiment disagrees with. That's harder. But
of course, in string theory, will they know it's wrong?
No, I don't.
I think it may be a case when we'll need AI.
Yeah,
because just like the AI that can play games, it might be able to do the mathematics.
Oh, yeah.
and tell us if a string theory is right. And if it spews out the right mass for the proton at the end, then you have confidence in the theory.
I've often talked it with my friend Frank Wilczek, who you know, and I was you even writing about him in your new book. But we've agreed that many people are afraid of AI, but one of the things that I find quite exciting is that it'd be interesting to see how it does physics, not just what it can teach us, but what AI thinks is important, the questions, those things. And so it'll be fascinating to
I think that'll be what humans can do, but it'll be able to work through these. And just like already they can test for drugs by simulating lots of chemicals.
Well, there'll be a black box.
High TC superconductors and things like that.
Well, it'll be, of course, what's interesting about it, at least right now, much of AI is it's a black box. So it can play Go better than a Go player, but you don't know how.
That's right.
It just does it.
Yeah.
And so it would be worrisome, I guess, if you had an AI trying to solve these problems and it spewed out 42 and didn't tell you why.
Well, that's right.
Yeah, and that's possible. That's possible. They could, and they could. It's possible that you would never be able to fathom why, even say string theory or whatever it is. There could be no explanation in terms of that we could understand directly that it might say yes. This is an accurate theory, and this is the prediction, but I can't explain to you how I've done it.
No, you'd have to be able to understand how it did it.
Yeah, well, in hopes we would, but we may have always said, well, it just works. But I don't know. It'll be interesting to see how that sort of thing transpires.
Yes. Well, you'd have to gain confidence in it doing lots of things right, which you could check before you.
And interestingly, one of the hopes of AI, or some people, is that quantum computing will potentially revolutionize what computers might be able to do. And Feynman, of course, was interested in quantum computing precisely. Well, one of the reasons he said he was because then computers would be their, if you wish to call it that way, their thought process would be directly dependent on quantum mechanics, and therefore they may understand quantum mechanics better than us and might be able to explain it to him.
Right.
Yeah, which I found since quantum mechanics was pretty good to him, I thought that was pretty interesting. Now, one of the things that impresses me when we communicate relatively often by email, and it seems to me you read virtually everything. And I'm wondering whether that is always the case, whether you always read voraciously from the time of a young man. But I'm always impressed that whatever I know that's happening, whether it's popular books or the media, you seem to be aware of it. And
well, I'm aware. I don't necessarily read it all, but I suppose I'm addicted to newsprint. So I read newspapers and
do you read
magazines.
You read hard copies more than
yes.
online?
Never online. Never.
Really?
Yeah, except when I'm traveling. But online, and I look at the archive of astronomy papers every morning.
Oh, there you go.
And so I read the abstracts, but I don't print out very many.
No, but that's very good that you dedicate and read. But for listeners, there's all physics papers and
even
astronomy
I wouldn't
papers.
say I spend more than 25% of my time on astronomy now.
But it's nice that you do. So all physics, it's a wonderful thing that now it's changed the way science is done. Astronomy and cosmology and physics papers all appear, even before they appear in journals, appear online in something called the archive. And people who like to keep, therefore it allows you in a way that was not possible before to keep in touch with what's at the forefront. And actually it's changed the sociology of science a little bit. It used to be when I was young and I was at Harvard, you used to get preprints.
That's right.
And you'd get preprints before anyone else.
Yes.
And it gave you a big leg up if you wanted to do work.
That's right. Whereas now, if you're in India, you get them at the same time.
Which is wonderful. It's democratized science in a really important way. Oh, I'm glad you agree with me on that.
I think journals are on the way out, I think.
Yeah, absolutely. I often... I found...
Books are not, I don't think.
Yeah, I hope not. I just worry that people can't read things longer than a tweet anymore.
Right.
But... I don't know if you've ever done this, but I found journals are so anachronistic for me that I've had papers on the archive that when I submit them to a journal and I find a particularly contentious referee who doesn't agree, I sometimes just said, I don't care, I'll just leave it on the archive because it's there and it's lots of people refer to it and it's really archival, which is really all journals are now in any case. So, but I don't know if you've ever done that.
I agree with that. I think the only case where you need refereeing, obviously, is if the publication is misleading.
Yeah.
If it's trivial, then it won't waste anyone's time.
Yeah.
So trivial papers, you can read in the archive. But if it's something which is based on wrong data, or something which is pretentious and might waste lots of time of some research student in India or something trying to understand it. It's not worth it. Then I think for protection of those people, there should be refereeing of very difficult and pretentious papers.
Okay, I know, I absolutely agree. And I've often even said in journals, when I was at Harvard, one of my colleagues was an editor of a journal, and he said if he had his preference, he would publish everything he got along with the referee's report beside it.
Yes.
And then you could read both and decide what and it'd be an interesting way of doing things. Let me ask you something else. You only read in print, not on the computer, at least newspapers.
Well, I mean,
in the news.
The newspapers, yeah. Well, I look at the BBC website, but I enjoy my newspapers.
Yeah, no, me too. But it's interesting because I wonder if that's a property of our age as well. Whether, for example, I remember kind of a phase transition for me. When I first started writing scientific papers or anything, I could only write them if I wrote them down by hand on a piece of paper first, and then type them if I had typed them myself on a computer.
Yes.
Now I could never do that. I can only write on the computer, and I can't. Have you?
No, I've made that transition too. Yes.
Yeah. Okay, because there's some people who haven't. So I went. Now, speaking about whether we're dinosaurs, as long as we go into that, there's a controversy one, a quote unquote controversy one hears about in cosmology, having to do with what's called the Hubble Constant, the expansion rate of the universe. Yes. And many people seem to think that some radical new physics is required because the rate of which the universe is expanding by different measurements is somewhat different, and then those measurements measure the expansion rate of the universe at different times, and within the statistical accuracy of those experiments, they differ and they're in disagreement. And some people say, well, that requires a profound change in cosmology. I'm old enough to remember when this expansion rate was measured in some units to be 100 plus or minus 5, and other people would measure it to be 50 plus or minus 5, and that meant they both couldn't be right, and not surprisingly, it came out to be sort of in the middle.
Right.
Do you think it's gotten a lot of press, this potential controversy? Do you think it's where do you fall on this?
Well, if you asked me to bet, I'd bet it will be reconciled.
Yeah, okay, good. We agree.
But obviously, I hope not, because if there was something fundamentally new, and of course, there are various explanations of some little phase transition in space or something like that, that would be very exciting. But I think if you asked me to bet, I would speak about this just this week, and I would bet that probably there will be some reconciliation.
Well, that's one bet we both be on the same side of, because after all, I think the point is there's a lot of, there's a long history in astronomy, and it's, as you point out, we can't do experiments; we can only do observations, which means you're subject. Not only are they difficult to do, but you're subject to things you can't control. You can't twist the knobs in an observation, and they're therefore what are called systematic uncertainties, namely things that you might not anticipate that might be biases in the experiment or in what you're observing that you can't control. And there's a long history. If history is any guide, there's a long history of people seeing problems that went away because we realized that things were just a little more complicated than they thought.
That's right, yes. And indeed, many false observations have been stimulus to theorists. Because you come up with new ideas.
But exactly, the false observations have driven people sometimes to the right direction. I remember when I was a young assistant professor at Yale, an astronomer, Gus Omler, who was a distinguished astronomy colleague of mine, argued at the time, based on what he saw, and this was probably in the early mid-'80s, that astronomy would conspire so we could never measure the fundamental constants. There'd always be some systematic uncertainty. We'll never measure the expansion rate. We'll never measure. And it's so amazing to see 30 years later how it's not just a factor 2, but measured to 5 decimal places.
That's right.
It's just, to me, that is, I guess I really never had confidence that we would be able to do cosmology to the precision we can do it now, even though I was pursuing it at the time.
Well, and it's much better data, of course, and also computers, and I think the microwave background data and the funny curve with all the wiggles which reduce the oscillations. It's wonderful that we can observe those things on the sky with high precision and match them to a theory, and that theory, if you calculate forward, predicts, roughly speaking, the galaxies and the clustering that we see today.
It really is amazing.
That's a huge triumph. And so I think that in particular should be, when the history of this period in science is written, up there with plate tectonics and the genome.
Yeah, I agree. I mean, this is
big, not just in astronomy, but in the whole of science.
Yeah, it's really remarkable that one can start more or less from first principles and produce a picture that looks, of something that one people might think is complex, but the structure in the universe that we see, that is remarkably similar to what we see. It's just, really is a triumph. Sometimes, of
and
course,
linking together observations made of when the universe was 10 to the minus 4, its present age, with what we observe today.
You're combining them together.
Yeah.
And that's a triumph, but at the same time, I think it's worth pointing out something you said earlier, because you hoped the Hubble constant, I mean, it would be nice if these measurements say that there's something fundamentally wrong with theory.
Yeah.
I think many people don't understand that scientists like you and me, or all scientists, really hope that we're wrong. Ultimately, because then there's work left to do. That if it's much more exciting if an experiment disproves some fundamental assumptions, because it really means that we have to go in new directions.
Well, that's right, or something unexpected, like if there were big circles on the sky in the micro background, that'd be exciting.
Yeah, absolutely. Well, I often tell people, and they don't believe me, that I do, physics and cosmology because it's easier than, say, biology, or it's certainly easier than the social sciences. And I want to make a segue now, because your career you have many aspects, and both institutionally and personally, you've moved beyond. As you point out, you spend less than 25% of your time now on cosmology and astrophysics. And in your career, you've had, besides being the astronomer royal and the Master of Trinity College, president of the Royal Society, involved now in the Center for Existential Risk, and a Lord in the House of Lords in England, and therefore been progressively more involved in the nature of science and society far more generally. Yeah. And you've been writing about that much more. And so is that a recent development in your life that you've been driven towards that? Have you always sort of had that fundamental interest?
Well, I've always hoped for that, but I've been luckier than I have thought I would be in having the opportunities. I mean, I've always been engaged with politics and going back to anti-nuclear campaigns in the 1960s and all that. And I went to Pugwash conferences in the 1980s, and indeed the first existential risks I started to worry about were, of course, the nuclear threats during the Cold War, which, of course, were far greater than any people realized at the time.
And still, I think, far greater than many people realize today.
Well, except there are fewer weapons around. So
a few, but 5,000 can still do almost as much harm as 50,000,
that's right.
Maybe just
so that was the first thing. But then I had the chance to get involved in science policy, etc., and more general. And so, and I've been very lucky in this, and that has indeed led me to write and talk quite a lot about these general themes, and about the way science is going, and about big long-term issues like climate and environment and extinctions.
I want to talk
that.
about a lot of those things. And it's interesting you say that, because young people often ask, how can I have a trajectory like yours, writing or speaking or being involved in these issues, speaking out? And what I tell them, and if I look at your life, I'd say exactly the same thing. The best thing you can do if you're a talented young scientist is do science. And then the more recognition, or the more significant your contributions to science are, the more opportunities you'll have, if you're interested in those issues, to have an impact. The broader the impact will be too. Do you find that? I mean, if you,
I think that's true, because I mean I'm not very good at any of the other things, and I've only been given the advantages because I'd established a reputation in my science. Yeah, and because one must exploit that, because we're all used to scientists who sound off about things they know nothing about in a dogmatic way.
In a dogmatic way.
I hope I don't do that. Yeah.
Well, I think that we all have to worry about that for everyone, and scientists there's a fundamental difference between science and scientists, and we have to remember that scientists are human. And I think that is, well, the question I would ask you, do scientists who have achieved some prominence have a responsibility, do you think, to speak out, or at least make an effort to have an impact, or not? I mean, on science policy, on the public, on et cetera.
Well, I think if their work has a direct relevance to policy or welfare, they should. They have an obligation to tell those in authority and ensure that if they've discovered something, that it is benignly applied, and we minimize the risk of the downsides if it has those. And of course, the atomic scientists in World War II, they were prime exemplars, because they they thought they were doing the right thing at the time, but when they returned to civilian life, they felt they had an obligation to try and harness the powers they'd helped unleash. And so those great men who we both were fortunate to know in the later years, Rotblat, Beta, and Piles, people like that, that they, I think, set an example which now needs to be followed by scientists in other areas, climate and environment, and certainly biology.
Yeah, exactly. I think, the scientific community, in some sense, has an obligation to, advise on issues, as you say, that are relevant to policy. And we're both involved in the Bulletin of the Atomic Scientists. I was very proud to chair it for a while, and in the tradition that the atomic scientists, Oppenheimer and Einstein, had created. But I think that at the same time, I think what's implicit in what you say is that if it's not. The other thing that worries me is that so often when young people are writing grant proposals, they have to have an educational component or a social component to what they're. When in fact there may be none, and so. By creating sort of an artificial need for people to do something that they're not interested in, I don't think it's very productive. I think scientists who are interested obviously should use that opportunity and the soapbox that they may get, but it's not a necessity. If a scientist just wants to do science, that to me, that's absolutely fine.
Right, and I think, well, obviously, it's good if they can do something educational, because in a democracy, it's important that everyone has a feel for science, because lots of the issues they have to address, be it on energy, environment.
I would argue every single issue of politics
or health.
There's nothing that doesn't, and that does worry me. Yeah. We need a scientifically literate populace in some sense. If they're going to choose in a democracy. Democracy won't work without an informed electorate, and need to be informed.
But we shouldn't moan too much. It's just as bad if they don't know the history of their country.
Of course. That's what I mean is they should be literate. So then literate means what literate used to mean. It seems to me in the turn of at the end of the 19th century, where you'd be able to have some general appreciation. Even then it's changed. But then a literate individual would have to have some cocktail party knowledge of what was going on in science. Now you could be proud. To have none in some sense. You say, well, that just doesn't interest me. And I think it's a shame.
So I think everyone needs to take part in education. But as far as public stances, then I agree. It should be only those who are good at it. But I think there is a point that is important, which is that the scientists who I know, and I guess you know, who've been political advisors, have often felt rather frustrated. And that's because politicians have an agenda where there are urgent issues and issues which are local, and to get them to worry about something like climate change, which is long-term and which will affect people in Africa more than their own constituents, that's a big sell. And I think the only way in which one can get them to engage with these issues is if they know the voters are behind them.
Exactly.
And that's why those charismatic figures who can influence the public are so important. And Carl Sagan was a prime example in our field. And I quote two recent examples where this happened. And it doesn't have to be a scientist. I mean, I think the Pope's encyclical on climate change and the environment in mid-2015, that made a huge difference to the forging of consensus at the Paris conference, because he got a standing ovation at the UN, and he's got 1 billion followers in Latin America, Africa and East Asia, and that had a big effect. And the politicians, if they know that the public is behind them, will do this. And a more recent parochial example in the UK, there's been a proposal by a fairly nondescript minister to legislate against non-reusable plastics, drinking straws and things like that, motivated by the concern of plastic in the ocean. And what's motivated that is the BBC Blue Planet programs fronted by our secular Pope, David Attenborough, and showing the stomachs of fish with this in, and the albatross returning from wandering and coughing up the plastic
for the child.
That's an iconic image, like the polar bear on the melting ice floe. And I think our British politicians would not have invested political capital in this legislation had it not been for knowing that millions of people had watched this and started to care about it. So I think it's those sorts of people Attenborough and Sagan and a few people now who are very important.
Well, I mean, one thing that's absolutely clear, and one of the reasons why I sort of got involved in the Bolt and its atomic and its doomsday clock, is that politicians don't lead; they follow. That every major change I know of, including when I was growing up in the Vietnam War, was driven not by the last people to be involved and were the politicians. You had to have a social movement at some level.
Yeah.
And I've always, in terms of climate change, I've been wondering, and nuclear weapons,
Yes.
what will be the Sputnik moment? What will be the moment where there's enough public? How can we get a public? Because if the
But we need
politicians
it,
know,
but, yeah.
and it doesn't matter whether it's a democracy or not. If leaders know that the vast majority of their population feels a certain way, it has an impact, and they get led by that.
Well, and of course, anti-slavery, civil rights in the US, gay rights, and all these things. They've started with a few people, then they've gained public support, and the politicians take it up. And there's a nice quote from Margaret Mead saying, "It takes only a few determined people to change the world.
Yeah.
Indeed, nothing else ever has."
Yeah.
And that's very true.
I think it's true, and I hope it gives hope to those, because these problems seem so grand that most people say, "What on earth can I do about it?" But we can all be evangelists in our own way. We all have to affect our children, their schools. If you go to church, the churches, etc. Interesting that you brought up the Pope, because I do want. We differ a little bit there, but I want to. When you in your most recent book, The Future of Humanity, you talk about a lot of issues, both problems and perspectives and hopes, but both from the nature of humanity and the nature of science, which was enjoyable for me to read, and obviously. I share
say
many
about
of your
the book
opinions.
that it covers a lot of things, and those who don't like it will call it a dog's breakfast. Those who like it more will say it's a smorgasbord.
Okay. Well, I guess I would call it a smorgasbord based on what I saw, and maybe partly because most of the things I agree with there, so maybe that's always a factor. But there are things I I want to ask you questions about. One of the issues you point out that is understated is the issue of population and the concern about a world where there could be between, say, 9 and 20 billion people, depending upon how it goes in Africa, and the ability to have a world where everyone has at least the opportunities to live a life that we like to think we have. I mean, without excesses of big cars and wasting energy, but a quality of living that is comparable to what we have now, and whether it's possible on this planet to have 20 billion people that have a quality of living. And it also, when it comes to climate change and pollution, the major negative feature in terms of climate change pollution is the number of people, because the more people, and that rarely gets discussed, I think, for a number of reasons, partly for the fact that at least one religion is not in favor of population control at all. So I wanted to point out, you point out rightly in the book that wheat requires 1,500 kilograms of water, whereas beef requires at least 10 times that much. Are you a vegetarian? I don't want to put you on the spot.
No, I mean, no, I always choose fish if there's a choice.
I don't mean to put it that way, because I know the same things as you, and I'm not either.
But I do think that vegetarianism is going to catch on. Two things by 2050 I predict firmly. One is more vegetarians, and the other is more euthanasia.
Oh, okay.
But we get onto that later, perhaps.
Okay, we'll get to that later. I know that when I told you I moved to Oregon, you said one of the great things about you might want to come visit, because one of the great things about Oregon is it has assisted suicide.
That's right. So it's the last place I want to go to. Yes.
The last place in that sense.
Okay. Yes.
But now let me hit you on the thing where I think I disagree with you a little bit. I'm often disappointed in the Pope. In fact, rarely am I not. Although I will say, and to be fair, we should point out that you're on the board of the Pontifical Academy of Sciences. By the way, I've always, to me, the Pontifical Academy of Sciences is an oxymoron, that term, because I don't view the church as the bastion of science. I never have. But although they support it, and there's no doubt, and I visited because of you. The only time I've ever been there is a conference that you I think helped organize on the long-term future of the universe, and I got to the pleasure of being there. And thank you for that.
And at these events, they have people of all faiths and none.
Oh, okay. No, exactly. It's not as if they try and impose that, but at the same time, in the Pope's encyclical on this subject, where it's in the chapter of your book on population that you actually discuss it. The whole point is that the church is opposed to the very thing that's necessary, which is contraception, family planning, and in some sense the ability of women in the third world to protect themselves against AIDS and other things. So I just found it hollow in the sense that
I disapprove of that.
I think you're just I know that you're more generous in your assessment of things. I thought that how can you be taken seriously as someone who's promoting a huge problem as a problem when your whole church is invested in promoting that problem? And I have less sympathy.
Well, I mean, going back to population, I think the population is leveling off. I mean, there's a special problem in Africa.
Well, there is, but that's exactly where the church is working so hard to counter what's necessary to be done in Africa, more than any other
Along
group.
with your President Bush.
Or President Bush and Trump.
Yeah.
No, absolutely. I'm not. But I can despise them. But they are in my opinion.
Yes.
That very church, which is directly responsible for most of the negative things that are related to population in Africa, along with misplaced political leaders. There's no doubt. Many of whom base their ridiculous notions on religious grounds, right? On the notion that somehow either contraception is a sin, or homosexuality is a sin, and people deserve to die. And so those misplaced notions, which are frankly religious ones, are holding us back from progress.
Well, they're not all misplaced, and I would say the church does more good than harm.
I know that's where we disagree.
Yes,
and we've written, and you've written about that, and you won the Templeton Prize.
I don't have any religious beliefs.
Yes, I know.
But I'd be sad to see the church getting weaker. And I'm happy to participate, just as lots of Jews who are atheists light their candle on Friday night because they want to preserve traditions. I'd be very sad if our cathedrals fell down, if there was no church music and all that, and if I couldn't be buried in a churchyard.
So I was reading about this. You don't call yourself a cultural Christian. A lot of us
absolutely.
I'm Jewish background. A lot of my friends will call themselves cultural Jews in the sense that they're atheists, but they like the tradition. And it's the tradition of the church you like.
Yes, I do. I grew up in that, and if I was in Iran, I'd probably go to the mosque in the same spirit.
And I don't mean to put you on the spot here, but I think it's a conversation that people should be willing to have in a respectful way. But you'd be sad if the church became weaker.
Yes.
But of course, the Church of England has become weaker.
Yes, I'm sad.
And you're sad about that. You'd be happier if the church had more control in education than it had. I mean, one of the quotes that I just learned here, since I came here is the Archbishop of Canterbury said that educating children is like engraving in stone. And when I read that, I just thought, it terrified me to read that because, of course, the education that he's talking about is not one I want children to have.
Well, I don't think our Archbishop would actually feel that. I think he's very broad-minded about these matters. But I think the point about religion is they emphasize what we have in common when so much divides us in modern society.
Because I tend to think that religion is always an us versus this thing. I mean, maybe because I was brought up in a Jewish tradition, and what I learned there is that somehow we were better. We were always oppressed, but we were always better.
No, but fundamentalism obviously is an evil, and I think we need all the allies against it. And I would see the Pope and the Archbishop of Canterbury as allies. And that's why I'm against people who rubbish them.
I don't want you to disagree with them. I think but I think we both agree that nothing is sacred in that sense, and therefore we should be allowed to disagree with the Pope,
of course,
and point out when we think that the Pope could do. Just as I was recently talking to someone here about someone who disappoints me all the time is the Dalai Lama. Although on a scale of things, he's sort of kindler and gentler than. So I think it's. But I think it's very important to point out that nothing is above sort of...
That's right. But the point is, I can't understand how people can actually believe religious dogmas.
Yeah.
Okay? But clearly some people do. Yeah. And you can't dismiss them all as naive or stupid.
No, okay? They're not...
There's something that we're missing if we don't appreciate this. And I think we should not attack them.
No, but maybe we should. I don't think we should ever attack people. Yeah. I think ideas are perfectly reasonable to attack, and that I think is, and so I think it's important to attack ideas that are wrong because beliefs influence actions, and if, for example, the belief that homosexuality is a sin influences actions, has influenced actions in my country and your country that I think are fundamentally irrational. Do you agree?
Well, I don't think you should use the word rational in the context of morality, because there's no rational morality. This is a sort of fallacy to believe that you can get ethics from reason. Most people who say that, they believe in a naive early 19th century utilitarianism.
I know we've talked about the difference. You can't get ought from is, but I do think it's irrational. Let me give you the reason why. Is a sense you can, if empirical evidence suggests something, then and your actions disagree with empirical evidence, I would argue that's irrational. And the empirical evidence about homosexuality is that that in most species that there's long-term homosexuality, that there's no evidence of immorality among homosexuals. So science can inform your morality, and if the evidence all points towards one thing and you do something else, I would call that irrational. It certainly would be uninformed. And do you agree with that?
Well, I mean, I share your views about homosexuality, of course, but I think in principle, I mean, if you take you can't get an ought from an is.
Well, you can't get an ought, but you can go a long way. You can say an ought that it disagrees with observation, and I would like to fly might be an ought, something I wish for, maybe I can believe I can, but the is if I step out the window, I'm going to fall, and so I think if our oughts are not informed by what is, then I think we can make, knowing what is may not determine what we should do. That I agree with you completely. And I have to say, my discussions with you over time have impacted on my own thinking in that regard. I really moderated them and informed them. But nevertheless, so it's sort of necessary but not sufficient, I'd say. So that, even if you know what is, reasonable people can disagree about what the implications of that are. But if your ought is not correlated to what is, I think we can say unambiguously that your ought is wrong. You don't agree?
Well, I'm not sure, because I think you can't assume there's a progress in ethics necessarily.
No progress, but look, I mean, the point is, let's take homosexuality. Once again, it's not unnatural. We know that 10% of sheep make long-term, homosexual, monogamous homosexual.
That's irrelevant to the ethics.
Well, it's irrelevant to the ethics, but if people say it's unnatural and goes against nature, that is wrong. And therefore, if that's what motivates their ought, we can say, that's not a justified reason.
I agree, if that's their reason, yes.
Okay, good. As long as we agree about that. I mean, there are lots of reasons that are subtle, but if you say, the Earth is 6,000 years old, and that determines, what I'm going to do, we can say, sorry, no, I don't. I may respect you as an individual, but I don't respect that notion, and I refuse to give it equal time, So I think it's very important to ridicule ideas from Jonathan Swift on. I think that ridicule is a useful tool, but but you're just a kinder, gentler person than me. I know that.
We need to have allies against fundamentalism, and that's why I think we should not criticize the mainstream churches. And also, if you were a teacher and you had some Muslim kids in your class, if you say they can't have their God and Darwin, then they choose their God and be lost to science.
I agree with you.
That's one reason why I think Richard Dawkins does harm rather than good.
I know, and we've had that discussion. I think we can encourage kids to question. I think it's all right to encourage kids to question their faith without telling them they're wrong. But you're absolutely right. I think if we say, what you think is, you can't believe what you believe, we should never do that anyway. I mean, I think we should, as educators, that would be a shame.
So I would not want to crusade against religion, that's what I'm saying.
I know, and I think it's important that there's many different views of it. But as I say, I don't want to belabor this, but I'm more willing to criticize influential religious figures.
Well, you've traced around the world with Richard Dawkins.
Well, I have,
this.
I have, but usually trying to traipse against scientific ignorance, which is what I'm really talking about.
Promoting atheism. Yeah.
No, I never promote it. I've asked people to think about
the so-called new atheists.
I don't know what new atheists are.
Well, this book just come out in hardcovers, which is a sort of conversation by those four people 10 years ago.
Yeah.
Now dignified with hardcovers.
Yeah.
It's sort of a undergraduate level conversation by would-be small-time Bertrand Russells, saying what other people said 50 or 100 years ago.
I've said for a long time, and it's hard to beat Bertrand Russell. I agree. Every time I think I've said something new and I look back, I've discovered in one way or another that he said it better and more deeply. That's true. But on the other hand, I don't. I'm surprised you use the word new. What do you mean by new atheists? I mean,
well, I've never used the word, but it's
I don't use the word. I mean,
use
atheism has been around for as long as religion.
It is certainly the phrase that they use themselves.
Yeah. Well, wow.
It's on the cover of the book.
Oh, really? That's really a shame. Because I don't understand what it means. Just like I don't understand what militant atheist means.
Right. No.
I just you throw, as I say, does it mean you throw pamphlets or books at people? I don't know what it means. Well, I want to. So I want to focus on you now. We've been having this discussion and giving my ideas, but let's conclude by talking a little bit about. I was fascinated to read a number of the statements you made, which were interesting to me or presented things in a different way than I'd been thinking, which is always wonderful. You called yourself a technological optimist and a political pessimist, which maybe explain that.
Yes. Well, of course, we wouldn't live the lives we do today had it not been for the technology of the 19th century and the 20th century. And we have the capacity to provide a decent life for the 7.5 billion people now. And I think, incidentally, probably for the 9 billion, maybe by mid-centuries, although I agree that we should hope the population goes down rather than up after that time. But I think we can hope that technology can improve us. But I think there's a big gap between the way the world could be and the way it is. And that gap, I fear, is widening. Because I think that the power of science is going up, but I think the problems of governance and avoiding the downsides and avoiding the mavericks who can produce damage that cascades even globally, that's going to cause big problems. And I think that gap between the way the world could be ideally and the way it is probably going to widen a lot. It's already wide because I think the reason I'm dubious about claims of ethical progress is that if you look back to the 14th century, life was pretty miserable. But there wasn't much they could have done to improve it. Whereas now, life is indeed far better for everyone in terms of life expectancy, education, health, and all the rest of it than it was then. But the gap between the way it actually is, with still 1 billion people in abject poverty in the world, and 2,000 people whose money could cure that poverty at the other extreme, this surely belies any claim of ethical progress collectively.
So interesting. So your attitude towards, say, Steve Pinker's argument about the Enlightenment is sort of leading that the world is better now than it's ever been, is moderated at least by this notion that, well, it may be better, but it should have been. It could be.
Well, that's right. I mean, clearly, I think it's a great book, and he's got all these figures about life expectancy and all that. And he and Hans Rosling and all that, they deploy this very well, and there's no denying what they say. But I think there are two things that he misses out. One is that I think he's lulled into underestimating these new emergent threats, which are rare but will be catastrophic if they happen even once. And that's what I worry a lot about in my book. And also, I think that there is a big gap between the way things are and the way they could be, even though there's no gainsaying that things are better for most people in the world than they were in the 14th century, even the 19th century.
When I was reading your book, I think that was the thing that it made me think the most, was that your statement that, despite the highly, even the fact that our conceptual horizons about the universe have improved so much from thousands of years to billions of years, and in every way our understanding of ourselves and the universe has increased. Despite that, there's a bigger gulf between the way things are and the way. And I thought, wow, I think that's a fascinating
and also
claim.
Interestingly, less disposition to think long term, because I think of the cathedral builders who built a cathedral which they knew would not be finished in their lifetime, and although their horizons in space and time were limited, that seems paradoxical. But the reason it's not paradoxical actually is that in the medieval period, they may have thought the world would only last 1,000 years, but they thought the lives of their children and their grandchildren would be similar to theirs. So they thought their grandchildren would be there to appreciate the finished cathedral. Whereas now, we have these huge horizons in astronomy and geology and all the rest, but we can't predict what the life will be like for the next but one generation.
Because technology is changing so fast.
It's changing so fast. And so I think that's the excuse, as it were, for some failures to plan long term, that we don't quite know what it'll be like then.
We can be pretty certain that predictions we make will be wrong.
Yeah, that's right. Whereas in medieval times, they were
it wasn't
they
changing so fast.
Despite all the uncertainties, the long-term trends were slow, they thought.
Yeah, no, I found that, and as I always get from you when I discuss with you, new insights and that was a new insight for me that I think is incredibly profound. And it's a problem. It's at the time when we most need long-term thinking. We're most discouraged from having long-term thinking.
Yes, by the rapid changes.
That's a real issue. And I guess it's happening in England too. But in the United States, we've had that problem for a long time. In that science gets harder, and you need projects take longer. Large science becomes big science.
Yes.
And in the United States, there's a yearly approval process, so that, for example, in the case of my field, there was a big collider being built in the United States.
Yes.
3 presidents had approved it, but all you needed was one. So it had been going for 15 years. All you needed was one Congress. And there's always a cycle of economics where there'll be a downturn. And the easiest thing to get rid of is a large-scale science project that's esoteric, because it just, you can say that. And so I am worried about our ability to address as a society large problems without the public outcry that, yes, we need to spend 20 years and a lot of money solving them.
Yes, of course, that project was a bit different from space, wasn't it? Because the public did care about space.
Yeah, they cared about it.
Whereas they didn't care about the accelerator.
Well, and I think it was a lesson. I don't know, in my field, what scientists learned the lesson of not courting the public first. Partly because of the Manhattan Project, we'd sort of been guaranteed money in this field and felt we didn't have to explain why we did stuff.
Physicists had huge clout at that time.
And we didn't feel I had to explain why. It was the bucket was open, and and suddenly I saw a new appreciation for people like me and others, but people who were willing, who the field felt it was necessary to actually explain why we wanted to do these things to the public, which should be there all along, because the public should understand why the money is being spent and should say, well, it's worth doing. And I, one of my favorite lines of any scientist, I've used about it many times, is Robert Wilson. Did you know Robert Wilson?
About civilization.
Whether the Fermi Collider would help in the defense of the nation. He said, no, but it'll help keep the nation worth defending, which I thought was a... Well, let's go to something dismal and then maybe optimistic at the end. You are concerned about a lot of issues. I mean, obviously climate change, population are two, but there are, and we both spent our time, both in your existential risk and future humanity efforts, and mine through the Bulletin of Atomic Scientists, looking at emerging existential risks, and there are some, and you want to just elaborate what keeps you up at night?
Yes, I'm not sure they're existential, but I do worry very much about holding the fabric of society together when it's so easily disrupted by just a few people, empowered by technology. We see this already with cyber attacks, and it'll be possible by error by design to reduce a pathogen and cause some biological hazards, which could spread extensively. So I think that it's going to be very hard to control this. And obviously, these new technologies need to be regulated. And there are, as we know, attempts to regulate genetics and all that on ethical and prudential grounds. But even if we have these regulations and they're agreed, then enforcing them is going to be as hard as enforcing the drug laws or the tax laws globally. We know how hopeless that's been. And I think the point is that it's not like nuclear facilities where they're large and conspicuous and you can monitor them and inspect them, etc. It's very, very hard. And this is going to lead to, I think, a growing tension between liberty, security, and privacy. And I suspect it's privacy that's going to have to give. And of course, the younger generation don't mind about that anyway.
Yeah, it seems it's already been given. I mean, it's already gone.
That's right. I think we're going to have to give up that. But still, I think we do need to worry, because these sort of long tail risks, which are unlikely but could be catastrophic, are growing. And if we think back, we both know Jared Diamond's book, Collapse.
Yeah.
He had 5 collapses, but none of them were global. They were local. Whereas now, I think, something bad in one continent is going to spread because of the global financial system and all the rest of it. No one escapes from set back globally. And this is something which does make me worried about the bumpy ride we may have through this century with these technologies. And there's going to be an arms race between the defenders and the attackers for cyber effects and all that. But the question is, it may be a problem. And also, I think society is getting more fragile. I mean, again, go back to the 14th century, half the population of some towns died the Black Death, but the other half went on fatalistically. If we had some sort of pandemic now, then I think before the number of casualties reached 1%, there'd be social breakdown because that would overwhelm the capacity of hospitals. And people would clamour for attention, etc. And similarly, if there was some breakdown in the electric power grid in the eastern United States, where the lights going out is the least of your problems, it's very catastrophic, then again you get social breakdown within a few days.
In fact, actually, you mentioned something in your book, and it's funny because I've talked to, I was actually in a film of a friend of mine, Werner Herzog, called Lo and Behold.
Yes.
But we are susceptible in ways we weren't before. For example, to get back to a field of ours and yours in particular, but if there's a large-scale solar flare that produces
that's right.
It could, 500 years ago, it wouldn't have been noticed.
No, that's right.
But now it could produce an electrical surge that would knock out the internet, and that, Werner's argued, would produce such social disruption. He thinks it would be one of the more serious things to concern. I don't know if it is, but if we couldn't, more and more things tied to the internet. From your refrigerator to to getting out of your house. We are much more susceptible to those kind of
that's right.
problems. Now, and for me, in my pessimistic mode, which is as I say often there, I tend to think that. I don't take a defeatist attitude, but I think when you talk about these things that may be possible, and you point out that we can't, it's hard to enforce. As you say, with nuclear weapons, there's a big infrastructure, but if you can rewrite DNA in your basement or in your garage, it's much harder to enforce that, or in a small scale lab. I tend to think we have to think that except for those things which violate universal human mores, and I think there are some, that we have to accept that sort of what's possible is going to happen. And what we need to do is think about how to deal with it when it does. That fortune favors the prepared mind.
Yes.
Which is why I think it's so important that people like you frame these questions, even if they're difficult to listen to and hard to think about. If we don't think about them, then we do it at much more of our peril than...
Well, that's right. So, I mean, I hope that by thinking about them, we can at least cut the risk by 1 part in 10,000, and thereby have more than earned our keep for doing it.
Well, I think you've more than earned your keep in many ways, and you've certainly more than earned your keep. Thank you for this discussion, and as always, I told you, I'm always enlightened by you. Thank you so much.
Great. We've gone on for hours. We haven't talked about space.
Yeah, we haven't even talked about space. I hope we'll have a chance to do this again.
Hope so. Yes.
Okay, you take care.
Yeah. Good.
The Origins podcast is produced by Lawrence Krauss, Nancy Dahl, Amelia Huggins, John and Don Edwards, and Rob Zepps. Directed and edited by Gus and Luke Holwerda. Audio by Thomas Amison. Web design by Redmond Media Lab. Animation by Tomahawk Visual Effects. And music by Rickolas. To see the full video of this podcast, as well as other bonus content, visit us at patreon.com/originspodcast.